Hi, everybody. Welcome to Geometry, Chapter 10, Section 2, areas of trapezoids, rhombuses, and kites. Another day of, oh, that's what I thought geometry was. But of course, I'm going to make it harder. So, as usual, don't get excited. Hope you guys are doing well. I hope you're getting off your computer and out of your actual beds at least a couple times a day. I've been trying to drink a gallon of water every day, which is definitely helping making sure I get out of my seat multiple times a day. It's been great catching up with all of you on our Zoom lunches. I hope more of you can join as I continue to do one every day at 11:30. Totally not mandatory. Just check in, see your face, any questions or thoughts or whatever. But just a good sort of touch back to what we are all missing. Most of you probably, I know I am for sure. And we're I'm recording this like almost 2 weeks in. All right. Before we start, the way we start all good things, in the name of the Father and of the Son and the Holy Spirit. Amen. Dear Lord, help me to recognize the reasons for decisions that are made by other people. Even if I do not agree with the reasons, let me carry out the wishes that others have. Help me to recognize that not everything revolves around me and that others need my help as much as I need their help. Help me to deal with everyday things that make me upset. Others have the same problems and they need help too. Help me to learn the importance of patience. I am not the only person who needs your help. Amen. In the name of the Father and of the Son and the Holy Spirit. Amen. Okay, so I mentioned the other day that a lot of these formulas are on that Archdiocese sheet. So when we're all together again, I will give you a copy so that you know what's coming. So of these formulas, what you do need to know, what you don't need to know. There are a couple they leave off, but the ones they leave off, you can derive. Means you can figure out, sort of putting other pieces together. All right, so first theorem, and again, you don't have to worry about these as theorems anymore. Proofs are gone, they're done. The party will be when we're all back together. So to find the area of a trapezoid, I need to find the sum of the two bases, right? So a trapezoid has two bases. One is on top, just because it's on top doesn't mean it's on a base. So the two parallel sides are the bases of my trapezoid, and I want to take the sum of those two bases, multiply it by a half, and the height. The height, again, is an altitude. So it has to, or rather not an altitude, but it's like the width of the overall shape. It can be given to you outside the shape as well, but an altitude is that overall height that it has, not like if I was given this slant height over here, that's not what I need. I need that overall height that meets in a 90-degree intersection with the two sides. Okay, so if I look at the problem below, actually, let me keep my little hand icon. Okay, so if I'm looking for, go away. If I am trying to find the approximate area of Nevada, they give me information. They tell me that I've got this distance here is 205 miles. This side over here is 511 miles. And then the overall width is 309 miles. I need to get this formula for a trapezoid because any four-sided quadrilateral, right? Four-sided is quadrilateral. Any quadrilateral that has two parallel sides is a trapezoid. So they're asking for the approximate area because like these, not that we ever really can do geometry by looking at it, it kind of looks parallel, but this kind of looks like a trapezoid. It doesn't matter that this side here is flat. I have two sides that are parallel. That is all I need to have a trapezoid. So it looks to me like the state of Nevada is a spin, a 90-degree rotation of this formula. And you know how I say like, oh, I wish I had one of those overhead projectors so I could actually spin it. Clearly I have too much time on my hands. Look, I spun it. So I can use this exact formula where my base 1 is going to be 205, my base 2 is going to be 511, and I have that overall height of 309. I've gone through that. Some of you guys are very visual and you can see that matchup, that spin in your head. I am not that visual, and I know others of you are just like me. this is why, you sort of you do the math the way you need to do it. If it means just turning your book, if it means turning the page on a test, I definitely want you to do that. When it comes to doing stuff online, which we seem to be doing a lot of lately, that's why I ask you guys to copy the pictures into your notes. Like when you're taking your exam on a computer, if you draw it on a piece of paper, you can spin that. You can't really spin your MacBook. I mean, you can try, but I'm sure whoever's proctoring your exam would think there's something wrong with you. Okay, so now that I have it spun, I'm going to use the formula, and you guys always know I write the formulas over and over again. Help me remember it. So area of a trapezoid is going to be half of the height times the sum of the bases. Now that B1, B2, that's just like fancy math speak for like I want the first base and the second base. These sub numbers just refer to a spot. It's not like B squared or B to the first. That's not what that is. So if I'm trying to find the area and I've got half the height here, now that we've rotated it so you can see how they line up, the height of this is 309 miles. 309. And then the two bases, the one up here is 205, and the one down below is 511. If I have to follow PEMDAS, right? I could distribute the 309, but there's no reason to. If I have numbers, I can do this evaluation. So why do some complicated math thing that I might make another mistake on? So if I take 205 and add it to 511, this sum in here is 716. And granted, you could also plug all this in your calculator, just making sure you got the parentheses in the right spot. So only the 205 isn't getting multiplied by the 309, right? Your calculator always does exactly what you tell it to do. If it gets it wrong, it's because you told it to do the wrong thing. So I've got half times 309 times 716, which gives me a gigantic number, which makes sense because I'm trying to find the area of a state. So my area, when I plug all of that in, is 110,600 miles squared, right? When we're talking about area, it's my units or miles times miles. That's why it's miles squared. If you want to get fancy and add a comma in here. And that is about the area of Nevada, right? We're finding an approximation. They even told me they were finding an approximation when they asked me the question, right? It's the approximate area of Nevada. All right, moving along. So has anybody ever counted how many times I say the stuff that we learn is connected? Someone should do that. All right, so I want to find the area of this trapezoid. But if I look at it, I'm not given enough information. Or at least at first glance, it looks like I'm not given enough information. We spent a chapter ago learning about special right triangles. So this is where somebody goes, how the heck am I supposed to know that that's what I'm going to use? The degrees of, right, all year you guys have known 180 degrees, that's a big number. We use that all the time. We talk about it with linear pairs. All triangles add up to 180 degrees. It's a number we use all the time, right? There was a while where I said the word linear pair, or I made someone in class say linear pair every day. 180 has a lot of things that connect to it. 90 degrees, that's another thing that when you see it, your brain should start to be like, oh, that means they're perpendicular. I know stuff about perpendicular. That's other things that come into play. We are adding 2 more numbers, or actually 3 more numbers to that list of numbers that make my brain go, wait a second, I know stuff about that. We dealt with the 45, 45, 90 triangle. That was one of our special triangles. And the other special triangle was the 30, 60, 90 triangle. I have a 30, 60, 90 triangle hidden in here. That if I connect S and I come straight down, I'm going to try to draw it to the best of my ability. That little piece in here now is creating a 30, 60, 90 triangle. So when I bring that line straight down, I know it's creating that 90-degree intersection here. And that means that angle S right here, that angle in there is a 30 degrees, sorry. So I have this 30, 60, 90 triangle. So in our last lesson, we talked about taking shapes and breaking them up. And then I told you guys to look at the notation, look at what you're given. I know, again, this is like a culmination of the whole year in one problem. When I draw this line, let's see, just for sake of consistency, let me name that point. If I just name that point, let's name it point T. If I look at this line I just drew in as ST, I know a lot of you, again, are like, why am I allowed to do that? If I say that ST is parallel to RQ, there's only one line that does that. We have talked about something passing through a single point and being parallel. There's only one line that exists like that. Also, when two lines are parallel, or two lines parallel are perpendicular to the same line, we've talked about that too. That's why I know I've got that 90-degree angle in there. Everything comes together. If this top line of SR is 5, that means if I look at TQ, that's 5, right? Because it's straight down. So this is more of that, those trying to find the area of a composite figure and adding it all up. I can break this trapezoid down, so you can do it in pieces. You don't have to use that formula above. We're going to, but I still need the height of this thing. So if this is 5 up here, I know this piece is 5. But they said the whole thing is 7. Well, that means that leaves, I'll put it down here, that leaves PT with 2 left over. So suddenly I have this triangle. I was going to freehand it, but like that would just be a hot mess. Even I know that. So if I separate this triangle off, I'm going to draw it a little bit bigger. So if I've got my triangle, okay, we'll pretend that's a 90-degree angle. I can tell it's not, but we'll pretend. So here's the triangle I just cut off, right? I just took a piece of this and moved it over here. So I've got 30 degrees up here. I've got 60 degrees down here. I am trying to figure out the height, and I know that this is 2. So that is just this piece. I moved it over. This is where it's awesome if you take notes in class, you take notes during my videos, so you can just flip back. College prep, I know that we did special triangles in class, but I have now done it as a video. If you want to go back and review that, if you were having any questions about that, which is fine. In that lesson of special right triangles, I taught you guys that in a 30, 60, 90 triangle, I'm going to freehand this one. It's going to be a mistake, but I'm going to try. In that, I knew it was going to be a mistake. In the realm of 30, 60, 90 triangles, the formula I told you that you don't have to memorize because it is on your Archdiocese formula sheet, the picture looks like this. It has a 30 degree, it has that right triangle. The triangle is drawn a heck of a lot better than this one is right here. 60. And what it says is the side across from 60 is supposed to be x radical 3. The side across from 30 is supposed to be x. And the side across from the 90 is supposed to be 2x. Well, I can use this fact here. The side across from 30 is 2. Well, the side across from 30 is supposed to be x. Perfect. I used the same variable twice. I know that's confusing. This guy here. I'll make this a red x. Now it's different. I'm trying to solve for the side across from 60. Well, the side across from 60 is supposed to be x radical 3. Well, if I just figured out that x is, or the side across from 30 is x, that's 2, that means in this case, the side across from 30 is 2 radical 3. And suddenly I have that last dimension that I was missing to be able to solve this problem. The height of this trapezoid is 2 radical 3. Now from here, if you want to use the area of a triangle, do 2 times 2 radical 2, to multiply that by a half, add that to the rectangle, you're going to get the exact same answer. If you go back to the formula that's up above, the formula that's up above says that The area of my trapezoid is supposed to be half the height times the sum of the bases. So now that I have all the numbers I need, the area is going to be half. The height is 2 radical 3. Yes, I want you to use the 2 radical 3. I do not want the decimal approximation. And then the 2 heights, remember originally it was a 7 and a 5. I just took that piece of 2 to figure out the 2 radical 3. But I still want to take 7 plus 5. Now, this is where your extensive Algebra 2 backgrounds are all going to come in. When I multiply this out, or combine like terms, figure this thing out, remember, there's no reason to distribute. I can actually do 7 plus 5 and get 12. One day I'm going to learn how to give myself the right amount of space. All right, so this is going to be the area of a half times 2 radical 3 times 12. When you multiply radicals, you multiply outside times outside and underneath times underneath. Okay. We've done work in geometry about breaking down radicals. I've told you guys my prison analogy, which is really universal when it comes to radicals, right? Not only does it help with the prison break and how we break radicals down, but it also helps the multiplication, right? I can't just mosey into a prison and do whatever I want. Same thing applies here. I can't just multiply that 12 that is not in a radical, that is not in prison, by the 3 that is. So when I actually give myself a little bit more space, when I take a half times 2, well, those knock each other out. And I've got radical 3 times 12. The area is just 12 radical 3. And again, no, I don't want the decimal. My units given originally were meters, so this is meters squared. Okay, so this is a fantastic question. It really does bring in so much of what we've learned over the entire year into one problem. That's why I always say, like, just because I give you a test back, don't like toss it. You should actually keep one notebook and maybe write stuff down. It's almost like the things I say with intention that's going to come back again. Okay, last example. And if we were in the classroom, I would have combined yesterday's lesson and today's lesson into one, but I am being a little nice. Plus, these videos are like time consuming to make. Okay, last one is the area of a rhombus or a kite. Either one of these works. Remember, the difference between these two shapes is they're both quadrilaterals. They both have 4 sides, but a rhombus, right? Rhombuses and rectangles make baby squares. A rhombus has 2 sets of parallel sides. A kite has no set of parallel sides. But regardless, this theorem, again, not that you need to remember it's a theorem, but this formula for its area still works. So, these chapters with the area and when we start doing volume, there's such, just plug and play that we do give you steps ahead of it before you just plug and play. That's what makes this a geometry class that happens after Algebra 2 rather than a geometry class that happens after Algebra 1, because that's all stuff you need to know. All right, so the formula here says, now this is a kite. The formula says I want one diagonal and I need the other diagonal. And I'm sure if I wanted to give you a proof and be evil, you could probably figure out where this theorem comes from if we're looking for triangles, but I digress. I need to know the entire diagonal. So I need to know all of line LN. So a piece of it's 3, a piece of it's 3. That means all of LN is equal to 6 meters. And if I look at KM, all of KM, yes, I forgot the line on top. All of KM is going to be 2 plus 5, which is going to be 7 meters. Okay, so that's like the tiny extra step before. So if I want to find the area of this kite, so I'm trying to find the area, which is going to be the first diagonal, oopsies, half of the first diagonal times the second diagonal. That means my area, and again, same sub numbers. It's just first and second. You're not squaring anything, no nonsense like that. So I want to do half of my first diagonal, 7. My second diagonal is 6. You can just hammer this entire thing into your calculator, and I get 21 meters squared is the area of this kite. All right. Please make sure that you take the quiz on this material tomorrow. They are open all day, guys, your quizzes. The SAT quizzes I had opened a little shorter, but your book quizzes are open for 24 hours. So that means if you wait until 11 o'clock at night to do it and Pearson's down, I have very minimal understanding. The entire world's trying to use the internet right now, so you kind of have to get while the getting's good. And honestly, I think Pearson's held up really, really well. I think in the 2 weeks, it's been a little quirky 2 days, which you know how much I fight with that. So I'm pretty content. All right. I hope you guys have a great day. If you have any questions on this, as usual, please post them in the comments below. If you want to send me an email about it, fine. I love hearing from you guys. I love seeing your faces for any way that I can see them. All right. I'll see you guys soon. Bye.